A circular swimming pool has a diameter of 24 feet. The sides are 5 feet high and the depth of the water is 4 feet. How much work is required to pump all of the water out over the side? Use the fact that water weighs 62.5 pounds per cubic feet. I like to start with a picture. So here we have our circular swimming pool. It is 5 feet high. The water is at a depth of 4 feet and the radius is 12 since the diameter is 24. Let's focus on a single slice of that water. The height of that disk, of that slice, let's call that delta x. And focus on how much work is required to pull that single slice out of the tank. Recall work is force times the distance. Now we'll look at the force for that single slice of water. We know it weighs 62.5 pounds per cubic foot. So let's talk about the volume of that slice. First of all, the area. This slice is a circle. Formula for the area of a circle is pi r squared. R in this case is 12. So that's the area of that slice, but then we want to take into consideration the thickness to get its volume. The thickness is the delta x. And now we need to talk about its distance. How far is that slice going to move? Let's label this height x. So that slice needs to move x feet to be moved out of the pool. Now work, if we use the limit notation, is the limit as n goes to infinity, the sum from I equals 1 to n. And now let's do a little bit of calculator work. 62.5 times 144, that is 12 squared, will give us 9,000. So we have 9,000 pi times x delta x. Integral. And now we need to talk about the limits of integration. Let's label the top of the tank at 0. That means the top of the water is at 1 and the bottom of the tank is at 5. So we are actually integrating from 1, the top of the water, to 5. And 9,000 pi x dx. From here we simply need to integrate. 9,000 pi x will divide by 2, that gives us 4,500 pi x squared. Evaluating from 1 to 5. Now plugging in those limits, 4,500 pi times 5 squared minus 4,500 pi times 1 squared, 4,500 times 25 minus 4,500 will give us 108,000 pi, and the units in this case foot-pounds. This is the work required to pump all of the water out of the tank.